This video will give you a background for how to go about doing the lab that I call the Bronsted-Lowry Acid and Base computer exercise. Once you're looking at this page on the computer, if you have it on your computer, you can easily take the link that's right here on the page and click it and go right to the pH meter. The other way is to go to the lab itself in my web page, and you can find the link there. Now, if we go to look at what it is that we're being asked to do, this box right here is where you're actually using the pH meter. When you find the pH meter, you're going to test it out and see what happens to get a pH reading. When you get a pH reading, you're going to be recording that in this column right here. Now, if that pH came from an item, well, in this case, say nitric acid, so if you have looked up nitric acid, you set it up as a 3 molar solution, and you dipped your pH meter, and you got a number here, you're going to have the pH here, and because this is on the acid menu, it's going to be right here marked as a strong acid. And why is it a strong acid? Because it's on the strong acid list. It wasn't on the base menu, and it wasn't on the salt menu. Actually, there's 3 salt menus, and anything from any one of those 3 salt menus, you're going to record here whether you have an acid, and you tell that by if the pH is above 7, you know it's going to be base. If the pH is below 7, you know it's going to be acid. Now, for salts, and let's look at some of the salts that you have on this guy. This shows up on the base menu. This shows up on the acid. This shows up on the acid. This guy is going to be on the base menu, sodium hydroxide. Now, sodium fluoride is a salt, so that'll show up on a salt menu. Sodium acetate here is going to show up as a salt. It's going to be on a salt menu. And sodium nitrate and sodium phosphate. So these last 4 are all salts. So to summarize, we have 2 acids, 2 bases, and 4 salts. So you're going to indicate over here whether when on the acid menu, if it's an acid menu item, you're going to record this as a strong acid because it's on our list. And what list are we talking about? It's the list of strong acids and strong bases. And so if you don't have this already, you need to write it down so you do have it. And you can see here hydrobromic acid, hydrochloric acid, nitric acid, sulfuric acid, and perchloric acid. Over here, the strong bases are all going to be metals with hydroxide ions. And these are just 3 examples. So all of these guys will be strong. Well, right here in this area, when you're doing your 2 acids, you're going to mark in the acid menu a strong acid and a weak acid. That'll be SA and WA. Now when you get to this guy, you'll find out that he is not a strong acid because he's not on that list. Or I'm sorry, he's not a strong base. He's a weak base. And this guy is a strong base because he's on that list of strong bases. So the 2 bases are going to be listing whether they're strong or weak in the base column here. And when you get down to these last 4, you're going to indicate whether they're an acid, a base, or neutral in this column. Now here we want a Bronsted-Lowry acid-base equation. And I'll do a Bronsted-Lowry acid-base equation with the ionization of our weak acid here. So we're going to have HNO2 is going to get together with water, and it's a guy that doesn't like to go very much to the right, so we get a little arrow to the right, and a big arrow to the left. Why? Because he's a weak acid. And then we continue on the other side, and we're going to have H3O, the hydronium ion, and the nitrite, NO2. Okay, NO3 is the nitrate. That guy was up here. Okay, so now we have our complete equation. Now we need to label it. This guy is my acid. This guy is my base. This guy is my conjugate acid, the C acid. And this guy is the C base. And I forgot my minus sign here, so let's get that in. And so now we have everything labeled. Now we need to tie them together in the Bronsted-Lowry fashion. So this acid is going to go with the conjugate base right over there, and the base is going to go with the conjugate acid. And then we have to read these directions up here. When a Bronsted-Lowry equation that supports, write a Bronsted-Lowry equation that supports your answer. Label the acid, base, conjugate base, and then connect them. Okay? So your equations here have to reflect whether they're strong or weak acids. So this guy, you're going to have an arrow in the middle between the reactants and the products, and that arrow is going to go one way, and you're going to write that as 100% because he's a strong acid. So now your job is to go to these guys. Is this a strong or a weak acid? And this guy, is he a strong or a weak base? And then you draw your Bronsted-Lowry equation to give that. Here, what we're asking for is for you to decide whether the change in pH of a hydrochloric acid solution from a 6 to a 3, when we have a change that's like that, it's a fairly big change. Doesn't look like much, but actually it's a lot when we talk about the hydrogen ion concentration, which is also known as the hydronium ion concentration. They're the same thing. So when we look at the pH, what does each pH unit represent? If the change goes from 6 to 3, we have a concentration that goes from 10 to the minus 6 down to 10 to the minus 3. This question is asking, what is that difference? Now, as we go to page 2, we're going to start with a new video, and I'll tell you more about that on video number 2 of the Bronsted-Lowry acid base equation, or acid base lab. Boy, I'll get it out. So, we'll see you on the other video.